Good morning, everyone. I think we're going to get started. Welcome to the Inspire conference, first of all, and welcome to this workshop on the using the SOS as an Inspire download service for observation data. I'm not only going to say a few words. My name is Michael Lutz. I work for the European Commission Joint Research Center, but the workshop's mainly been organized by these two guys here, Alexander Kotzev and mostly Simon Jerka from 52 North. I just wanted to give you a small bit of context on how this work that the two guys are going to present to you afterwards fit into the overall framework of the Inspire maintenance and implementation. As you may know, there is now a framework for supporting the maintenance and implementation of Inspire, and we have set up a work program of a number of things that we want to address over the next year or so in maintenance and implementation. And one of these issues in the work program, number 7, is related to the technical guidelines for download services. And we've basically, the issue that we want to address in this topic is that the current download service technical guidelines are mainly based on the web feature service for the direct download. And that's not very suitable, let's say, for data that is related to observations, but also related to coverages or to tabular statistical data. So the idea is that we will work in this work package to see how we can extend the technical guidelines based on other standards than the WFS, namely the SOS for download for observation data, the WCS for coverage data, and the TJS, table join service for tabular data. For the first part on the SOS, we have launched a study in the ARENA action of the ISA program. The ISA program is a program supporting interoperability of e-government in the European Union. And one of the actions there is ARENA, that is looking at reusable components for interoperability in Inspire, but also beyond. And basically, we have been working on the study with 52 North, and you're going to hear all about what they've been doing in the workshop. The work on the WCS and the TJS have not yet started, but we will be discussing in these days on how we move that forward as well. Just a few words about ARENA. It's been funding this activity. As I said, the main thing is about establishing a collaborative platform and help sharing best practices around the implementation of Inspire, but also beyond for e-government interoperability. And we've done 3 main things in this project. One is to have an inventory of existing tools and software that you can use to implement Inspire, but then also to identify other platforms and policies that deal with spatial data exchange. And most importantly, we have been identifying a number of missing items that help interoperability within Inspire, but also between Inspire and other sectors, and to develop some of the open source solutions to fill in these gaps and missing items. And one of these missing items that we've identified is the SOS as a download service for observation data in Inspire. Again, here you have a bit of an overview of what the things that we've been, the project that we've been running in ARENA over the last year or so. Maybe one to note is the registry, the Inspire registry that has been developed under ARENA as well. But we have done a number of other things related to cloud computing, data interoperability, and so on. So just to note, when we say missing item, it's not necessarily a piece of software, but it can also be some additional guidelines, best practices, and other things that help people to implement Inspire and to connect Inspire to other sectors and e-government in particular. That's it for me. And then I'll leave it up to Simon to go on. Thanks. any questions? Sorry. It's just the introduction. The questions.
Okay. Okay, thank you. So I would like to give you a short introduction in the overall structure of the workshop and a bit on the background that we will be dealing with. First, a quick look on the agenda. We will start with the welcome of Michael, this introduction, and then also we would like to do a short roundtable to understand who is attending this workshop, to also get a better feeling how to set some specific points in the workshop, which we will discuss a bit more intensively. Then you will get a bit more on background information about the feasibility study we have been doing with the JRC by Alexander Kotzev. He will show you a bit more why has the study been launched, what's the motivation for the SOS, for why are we looking into the SOS for Inspire. After that, you will get a view on the proposed update of the technical guidelines for the Inspire download services. So that's something we have been preparing together with JRC in the project, which Michael has mentioned. And then also have a look on if you are a data provider, how can you approach this to deliver your data through the SOS in an Inspire compliant manner. And then we will finalize this session, could also be switched into the second session, depending on how we are in the time, a short hands-on, how to interact with such a SOS server and how to get data out of it. Then this workshop is split in 2 sessions. The second session is intended to be a bit more interactive. So we have called for presentations by participants. We will see in the break if anyone is there who would like to present something about his own experiences with SOS requirements or any other statements he or she would like to make. Then we will go a bit more into discussion about requirements from data providers, what's important regarding provision of SOS servers, and then a conclusion. Yeah, that's good. No problem. Okay. Okay, great. So depending on how the second session will be, how much discussion there will be, we have also prepared some further demonstrations on potential client applications that you can use, some deployment scenarios you can also learn a bit from. So there we will see generally a bit more interactive interaction between us. So now let's look a bit more on the motivation also. So for example, we have scenarios like 2013, we had severe floodings in Germany, and what was important really is to get more situational awareness by sharing data, and sharing data especially across borders. So having interoperable access between different stakeholders, different players, and then we need a mechanism to bring all these different types of observation data. In this case, if you are not only in flooding scenarios, that also applies to environmental factors, you need some way to bring also latest observations into one place. And one purpose of the SensorWeb is exactly to ensure this interoperability. So SensorWeb is the larger framework we are talking about here. And the idea behind the SensorWeb concept is to reduce the work you have to do when integrating sensor data from different sources. So that may be hydrological data, that could be environmental data like air quality data, which is at the moment a quite hot topic here in Europe. And you have a common model, data model, common encodings, common interfaces, how to bring this data together. So it's basically the idea that is also behind spatial data infrastructures, but just extended also to this more dynamic type of data, the sensor data. To realize this vision of a sensor web, there's the OGC Sensor Web Enablement Framework, in short SWE. And that's basically a suite of several OGC standards that can be used for building such a sensor web. Just as a quick overview, the OGC Sensor Web Enablement Framework is quite comprehensive. However, for the purposes we are discussing today, sharing data in an interoperable fashion, there you need only a few of these standards. So generally, sensor web enablement is divided into two big parts. We have the data models and we have the interfaces. The interface we are going to talk about today is the SOS, the Sensor Observation Service. That's a data access interface, which we can use. And on the other hand, you have especially O&M, that's observations and measurements, which is an ISO and OGC standards for modeling observation data. That's the ISO part of the standard. And for encoding data in XML, that's the OGC part of that standard. And O&M is also already quite relevant for several of the inspired data themes where people already have been looking in how to apply O&M to these types of data. What could also be relevant, SensorML, sensor model language, that's more about the metadata. That's information, for example, about the precision of the sensor that has delivered a certain measurement. So that gives you all the information you need for better interpreting and being sure, can I use a certain measurement really for these scientific purposes that I would like to follow? So let's pick out the two most important standards from the background. Observations and measurements, as I mentioned, that's really used for the encoding of the data measured by sensors. And for example, it defines pretty fundamental stuff that if observation has a timestamp. Could be a timestamp or a time span which is associated. It describes which timestamps that we have. So for example, an observation has a timestamp when it was published. Then it could be the time when the observation was taken. So when the value applies to the real world phenomenon. You could also define a validity of the observation, for example, in case of predictions. So that's defined. Then, of course, an observation has always a value. Depending on the type of observation, that could also include the unit of measurement. It is always associated to a feature of interest. That's the geospatial object for which the measurement applies. So if you have a measurement of air quality here in Aalborg may be the feature of interest because that's the geospatial object to which the measurement applies. O&M 2.0 is the latest version, and you can see ISO has standardized the data model. That's the more abstract part. And the XML encoding, how this abstract model can be encoded in XML, that's part of an OGC standard. Then we have the OGC Sensor Observation Service. That's complementary to this O&M data model specification. If you want to serve O&M encoded data, then the SOS could be the interface of your choice because it's some kind of mediator between the sensor and the sensor database where all the observations are stored and the clients which are consuming the data. So it defines specific requests how to ask for sensor data, how to filter sensor data so that you can specify I'm interested in data from a certain area, for a certain time span, for a certain observed property, for a certain parameter, from a specific sensor. So there are dedicated filters describing how to access and how to request specific sensor data sets you are interested in. And that's important because here you get the interoperability advantage because you have a very clear interface how to ask for this type of data. And as you can see, the returned data formats are then O&M. If you ask a SOS for observation data, you get back observations and measurement encoded data. Or if you ask for the metadata, that's also served through the SOS, that's then SensorML. SOS is available in version 2.0 for a couple of years now, I think. It has replaced the 1.0 version, and for Inspire, for this download service specification, there we go now for SOS 2.0. SOS and all these sensor web technology has already been applied in several thematic domains. So in hydrology, there's a very intensive discussion. In hydrology, you even see that there's WaterML 2.0, which is an application profile of O&M. So O&M can be customized to specific domains. Air quality is a very big topic because you have the e-reporting activities here in Europe for ambient air quality. There, the EA is expecting a specific O&M schema, how the data should be delivered to the EEA. It can be applied to weather monitoring. There's also this big topic of humans as sensors. So where you have human observations, for example, in the case of disasters, where humans can report what they see, that's also some kind of observations which can be served through SOS and O&M. It can be applied in traffic, so traffic density, delays, geology, so measurement profiles, whatever. So there's a lot of different domains where these standards can be applied, and they are not limited to just one specific domain. They can be transferred, perhaps customized, but they can be transferred to different topics of data. So that's the quick introduction. What we are talking about, sensor web, what's that? Before we go to the introduction from Alexander Kotzev, why this study and our project has been set up, I would like to go quickly through the auditorium and see if you have any experience on SOS, what's your background. So a short introduction from everyone would be great. So perhaps, Alex, you can.
Good morning, everyone. I'm Alexander Kotzev. I work with Michael in the Research Center. The STAR team, I've been engaged for the past 1.5 years with the air quality reporting initiatives, where all the member states have to report big volumes of air quality data to the European Environment Agency, where sensor observation service might play a really important role. So also I'm interested in working with a broader topic of how those
Michael Lutz, RT. I'm maybe here to hear what the broader community thinks about what we've been doing over the last half a year or so. This is the first time we carry really to a wide audience. To hear what you think.
Yeah, so this is Heather. I'd like to see that we're supporting many customers with implementing fire, especially most of the data on the side. I'm just interested or curious to see if there's something that you can do for us to support this. Yeah, just to get more.
My name is Antje Kugler, also from Java, and we have very similar interests in what we're doing with it. Find that most of our customers are quite comfortable with Inspire new services now, that Inspire download services is a bit more difficult, I guess, and interested to see how the sector is not working.
My name is Paul Janssen from the Netherlands, in work with Grenoble. I'm a data modeler myself, and we have some special interest now in the Netherlands in the Internet of Things and the sensor web concept, so that's why. But I'm in a learning mode right now.
My name is Nicholas Hardeman. I'm from the University of Bonn. I work for the research group on fecal hydrology and water resource management. And we're dealing with flood risk management as well, so we are very interested in dynamic data and time series. So I just started with the topic, and I'm curious to see what you develop.
I've been working with several agencies in Sweden, both from one side and helping with network services, and there's definitely a need that there are also have
Didier Bovici, I am part of the project called Corporate. We do crowdsourcing, and we are planning to use SOS services.
I have to pass the mic so we have it on film as well.
Shall we restart?
Okay. Is it working?
Should be here.
Okay. So my name is Ilkka Rinne. I'm from a company called Spatinel, and we are doing technical monitoring and quality of service improvement for spatial web services like the Inspire download and view services. And this is a very interesting topic for us because we are looking into SOS also. So this is very interesting to hear what's the future of the SOS and in the Inspire scope especially.
And my name is Thomas Hjort from the Nature Agency here in Denmark, and I don't know nothing about the SOS, but I do know that we have a lot of sensors out there in the field, and therefore it could be interesting to know about the SOS. I work as a project manager, so I'm not involved in the finer technical details.
Marie Lambois, IGN France. I don't know much about SOS, but we are currently working on guidelines about download services, so I'm here to see if we should include something new.
Pauline Gobert. I'm working about the implementation of Inspire in my region, and we don't use yet SOS services, and I don't know nothing about it.
Okay, I'm Ralf Becker from the Institute of Geodesy and Geoinformation of Aachen University, and we are starting several projects using SOS service, and so I need some more information about it, I think so.
My name is John Peel Hansen, and I work for the Norwegian Hydrographic Service. I don't know anything about SOS, but we have, like Denmark, many sensors out there. Especially, we mostly have tidal sensors and water depths and stuff. Yeah.
Hello, my name is Paweł Soczewski. I am from Poland, from GIS company. Now my company implementing Inspire network services in Polish Meteorological Institute and Water Management Office.
Hello, I'm Etienne Tafoureau from BRGM, the French Geological Survey, and we implement SOS for geological and hydrogeological monitoring.
Hi, hello. My name is François Pruner. I'm working on cataloging geographic informations, and I'm interested in linking sensors with catalogs.
Hello, I'm Mika Treger from France. I work at Ifremer, which is a marine data center, and we handle different sensors, different type of data type, for example, time series, profile, and trajectories. And we start to study SOS to disseminate this dataset.
Hello, I'm Erwan Quimbert from France as well. I work with Michael in the same team, and I'm interested about all SOS.
Hello, my name is Daniela Hogreve. I'm from the German SDI Coordination Office, and I'm just here to hear more and learn more about the SOS in the Inspire context.
Hello, I'm Lucia Kondrova from the Czech Geological Survey. I don't have any experience with SOS, but I was interested in how it could be used, for example, for geophysical measurements or seismic measurements.
Hello, I'm Olga Moravcova, also from Czech Geological Survey. I'm metadata custodian of Geological Survey, and now I'm develop a metadata system for minerals for EU.
Hello, my name is Paulina Kamińska from Polish Geological Institute. I would like to hear something new about SOS and about download services, because our customers expect that we will share in this way our data. Thank you.
My name is Natalia Smirnova. I'm from Latvia, from State Land Service. We're responsible about some inspired themes, such as cadastre, address. This theme very interesting for me.
Hello, my name is Saulius Prižginas. I'm from National Land Survey of Iceland, and I'm working on Inspire implementation in Iceland. And I am also a part of the ENV Plus project, and I have no experience in the SOS, so I'm here more like to observe and learn.
Hello, my name is Barry Evans. I'm from Aberystwyth University, also working on the Cobweb project, which Didier mentioned. We're looking at using citizen science to support flood modelling. Interested in hearing more about SOS.
I'm Jani Kylmäho from the National Land Survey of Finland, from the SDI unit, and we are looking to do some work with SOS and WCS services next year, how to integrate them into the Finnish SDI.
Jari Reini, also from National Land Survey of Finland, so same topics as what Jani explained. Furthermore, we are also responsible of Inspire training, so I would like to learn a little bit more before giving any courses in Finland.
Hi, my name is Richard Mitanchet. I'm working for CEREMA, a French public institution, and I'm involved in standardization.
Hi, Fanny Lecuy. I work for the French Navy Hydrographic Office, and I'm just here to learn about SOS and see if I can use it in my organization.
And finally, Jan-Erik Bulens from Wageningen University Research Center in the Netherlands. I'm also involved in the developments over there, right, around the Internet of Things and the sensor web. So I would like to have some new insights and developments coming on and learn about what is possible with this kind of interoperability and standards in the field of sensors.
Okay, thank you. I just saw that I forgot to introduce myself, so I'm Simon Jirker. I'm working at 52 North as a project manager and consultant. I've been involved in this sensor web activities, I think, for a couple of years. And yeah, I'm working in projects where we help customers to set up such sensor web infrastructures, work together with the JRC in this context, also in a project, and are also working on open source implementations of these standards that we will see today. Okay, now I would like to give the floor to Alexander for his presentation. Thanks.
So what I would like to try and do with this presentation is to try and show you why do we actually need SOS as in the context of Inspire, and what is the value added. But before that, a few words about the context. Internet of Things was mentioned by several of you. We have to realize that the number of devices that are connected to the internet is rapidly growing, and it is actually there are more devices connected to the internet from 2008 than there are people connected. And those devices, some of them being sensors as well, are expected to reach 50 billion by 2020. So this is a really big explosion in the data that is available out there, which is creating, let's say, a revolution in the way we measure, in the way we try to understand our environment. So this is the broader context in which we should position the topic of Inspire and sensors. At the same time,
Inspire is a directive which is focusing on the spatial. So this is also encoded in the name of the directive. So there is a strong focus on the geographical and of course there are also observations, but the topic that led to the creation of the directive is on geographical data. However, there is a guidance document that deals with observations and measurements, and this is particularly relevant for the annexes 2 and 3 of Inspire. Those have been created in response to the necessity to provide such observational data, this guidance document deals with the topic of how to actually encode data itself. SOS is a solution that can be used on the service level to disseminate such data, and it has been identified as one of the possible candidates for download services within the technical guidance for the Inspire download services. It's just mentioned there briefly, basically the technical guidance stating that there are solutions, example solutions out there, and the possible directions for development of the technical guidance is in the direction of SOS. What we did before we started this work with 52 degree north, starting from this an air quality project of the GRC supporting member states in reporting to the EEAs, was to look at actually several things related to the SOS. First of all, comparison with other solutions that are out there, to see whether do we really need that? Can we make use of the other solutions as they are so that we can satisfy the need to serve observation data or not? Then, is it mature enough? That's a standard. The standard is a nice thing, but are there solutions? Are there actual implementations that can help member state reporting authorities to actually implement? Because if we follow a standard and if there's no software that can back that up, then it's not really useful, right? Then we looked at licensing issues. We don't want to support from the perspective of the technical guidance documentation solutions that can lead to lock-in. If there's only one vendor, if the solution is proprietary, then maybe it's not a really good idea to have such information provided in the guidance documents. And then there was also work in 2013 of mapping what's the legally binding bit in the Inspire Network Service Regulation with what is actually the SOS2 standard. So how do those two different worlds interact with each other? What is from one legislation, how to map to the standard in the SOS world? First of all, why not use the solutions that are out there? In the technical guidance documentation for Inspire download service, there are already two solutions. Those are Atom and the WFS. Just one comment. Inspire download service is distinguished between predefined dataset download service and direct access. Predefined, you should understand as bundling a whole dataset and serving it through a solution. The direct access is a more flexible solution that can allow the users to actually interact with the database that is behind. So why not use those? We looked at Atom, not really a good idea for observation data. Why? Because it's not really being created for such a purpose. If we're dealing with a huge volume of data, this can easily lead to situations where the service, the Atom download service, will not be able to deliver. WFS considered as a better candidate, but WFS turned out to be really flexible, meaning that WFS can serve observation data, but there are so many different ways of making this possible that interoperability can easily be broken. One country, one reporting authority implements a WFS following one approach, another again with WFS, but then those two services cannot really interact with each other, and it's not easy to combine data from them both. Then also, the name itself, a web feature service, focuses on geometry, on precisely locating data on Earth, but then not really suitable for observations. We have to consider that, speaking of observations, we can have situations where we have one feature, but then there is terabytes of data that are associated with this one feature. Air quality, there are many, many examples like that from the stations that measure. So then we looked at the maturity and availability of solutions, both on the server service side and on the client side. And we identified quite a lot of them, the majority being open source, but also proprietary solutions. So we consider it as that there are different opportunities for implementations, and that the standard and is mature enough so that it can be used for extending the technical guidance documentation. This is just a list, some of the client solutions, both desktop solutions and web-based clients that can consume data which is being served through the SOS. And then came this pilot study, which we're happy to be working with 52 degree north from Münster. That basically, it's, as Michael mentioned, within the framework of the ISA program, the ARENA project, that has the idea of bundling together an open source solution and a proposal for an update of the technical guidance for inspired download services. So it's not only the guidance, it's the guidance plus the actual software product that together can help reporting authorities, that can bundle everything together so that a reporting authority which wants to go the Inspire way has everything that is necessary. The actual activities, and Simon will be showing our progress with those, are first of all, have a look at the Inspire documentation, then familiarize with the technical guidance for download services, propose an open source implementation based on those, extend the technical guidance documentation, and give examples for everyone to use. We implemented, have this open source implementation right now, and we also loaded it with example data. This is an air quality station which is located in Ispra. We have 6 months of observation data loaded there, so that it's also immediately that the solution is live. It allows also interaction with data so that one can familiarize with what we actually did and how the service delivers. Then, because this is a project, like every other project, it has got a deadline which is quickly approaching. We don't want this to be a one-time exercise. We want this to continue to be evolving. That is why within the context of the MIG there was a proposal for a subgroup on the sensor observation service that can actually ensure sustainability of the work which is being done by this study, and then to keep on maintaining the work and to keep on evolving the SOS as a download service. So the idea is that this continues after we should be over by the autumn this year. So the MIG will take over this work and will be formally have the mandate to evolve those activities. And then finally, after this brief introduction, What's the way ahead for the download services? We want to also be looking, as Michael mentioned, at 2 other candidates for Inspire download services, following the same approach as the one that we did with SOS. Those 2 being the web coverage service for the raster, for the coverage data, and the table joining service for statistical data. For instance, this very interesting work being done by Juno here for TJS with Eurostat information. We want to look at that, other examples, and then have the same approach. And then for the SOS itself, we should focus also on clients, because service we more or less have covered, but it's important that we can have clients that can consume such information. And we're also looking at onboard service capabilities with cheap devices, this in the context of the Internet of Things, having the ability to actually install, deploy such solutions on a device, so that then we can actually have interoperability on a lower level. So that's basically where we are and what we have been doing during the past months. Thanks. Any questions if you have at this stage, or can take later?
Just briefly, what's the timeline of the MIG software? So what's the expected time to get the download service recommendations?
No, actually, we have a proposal for an update of the technical guidance, which is in draft mode right now. So we will be able to discuss in the next presentation. And then the MIG group is established from this year. I think the mandate is until the end of 2015. So that's the logic.
One of the first tasks of the group will be to set up the more detailed planning. Yeah. I would hope that by the end of the year we have a proposal for updating the technical guidelines.
So there won't be any changes necessary or foreseen changes for the implementation?
No, just the technical guidelines. I mean, that's the foreseen to work on the technical guidance.
Yeah, and we speak about proposals all the time because it's not the mandate of this project to actually have something approved. It's just we're proposing, and then it's the MIG that then decides. So, yeah. Okay, thanks.
Okay, thank you. As in the roundtable round, it can be a bit clear that there are some people who are new to SOS. Before I go into the technical details of the technical guidance update, I would just like to have a quick demonstration what we are talking about, which type of data. And what we have here in place is a short demonstration. What you can do with this SOS, how you can access data. And what you can see here, for example, we have now connected through to 3 SOS servers. One is running in the Netherlands by GeoNovum. That's the one marked in green. That's a time series from 1 station in the Netherlands. There's data from multiple stations available. We have data from Belgium. That's the blue one. That's also served through the same interface, so that we can integrate data from different countries into one client. We have also data from Sweden. That's the red one. And we can use the same interface, same data models to bring the data together and show that on such a map. We have some quite comprehensive data sets like Belgium. They are serving data since 2011 until basically today. So that's the latest measurements. And you can see here, 16th of June, you can really deal with near up-to-date data in such a client. Here we have air quality data. You could also add other data sets. So that's the data from Sweden. We have a whole list of different data providers serving their data through this interface. We can also go to other domains like hydrology. Someone was talking about tidal data. For example, we can go also to the German coast. We have such services here. There's one on the island of Sylt near the Danish border. We can access the data. We need to clear up a bit. Check. Matthew. Okay. Select that station. Okay, there's some outage of the service, but what you can see is you can easily bring data from different data providers together. If that sensor doesn't work, let's try a different data provider, like this one. That's a regional authority. You can even check which stations are there, which parameters are they measuring. So you have different ways to integrate such different types of sensor data. That was just a short look to the side. And now we go a bit more into the technical stuff. And what I'm going to present you now is an overview of this proposed update of the technical guidance that we have mentioned. So the current state of the technical guidance is that we have included the ATOM and WFS options to realize an Inspire download service. And what we have done is to enhance this with additional sections. So we are mapping these general requirements regarding an Inspire download service to the SOS interface. And we have added 2 sections. On the one hand, so that's the mapping. And then on the other hand, we have included 2 different sections, one on how to use the SOS as a download service for predefined data sets, and the second one is how to have the direct access download service. Basically what you can see if you look at the SOS interface, as soon as you have set up an SOS, you basically immediately cover both of these with one, because the SOS already has built in all these functionalities you need also for direct download access. So let's have a bit more closer look at the SOS interface. So we have different elements in there we need to consider for this technical guidance update. The SOS core conformance class. So this SOS specification at the OGC is structured into different conformance classes requiring different types of functionality from the SOS. The core conformance class basically says an SOS has to provide an operation get capabilities. You know that from all OGC services, to describe the content and the operations the services are providing. You have a describe sensor operation. That's for getting metadata about the measurements, processes, the sensors which have acquired the data. And you have the get observation operation. That's the core functionality. With that operation, you are able to access the data available through the SOS. And you have lots of different filtering options how to ask for this data. Then we have the spatial filtering profile, which will also be relevant for this activity. That describes how spatial filters can be applied to ask for certain sensors, for sensor information, like filtering for specific stations through a bounding box. That's covered in there. Then we have the XML encoding part of the SOS specification. So that's a bit modular. You have first the abstract model of the operations, and then a specific part which describes how these operations can be encoded in XML. So how to describe that. You have that. Oh, sorry. I here on my screen. Then you have the key VP binding, key value pair binding. That's basically the get operations, HTTP get. How to invoke the get observation, the describe sensor, get capabilities through a basic URL. And then we have filter encoding. filter encoding that's used for querying certain more sophisticated elements, and the basic requirement in the SOS is that they have to be minimum spatial and temporal filters. That means minimum spatial filter that you can query observations based on a bounding box. Minimum temporal filter is about that you can, for example, ask for data during a certain time period. So that's described in the SOS standard, and now we have to take this basic functionality provided by the SOS and transfer that and look how can that be mapped to the functionality that has to be provided by a Inspire download service. And what you can see here is a quick overview how this mapping has been achieved. So we have this get download service metadata operation. That is quite obvious. You can map that to the get capabilities operation of the SOS. Then get spatial data set. That's for downloading a whole data set. That could be an observation set then in this case. There we have the get observation operation because that's the operation where you get the data that's of interest from the SOS. Describe spatial data set. That's more about the metadata about the data set. In the SOS, in the capabilities document, we have so-called observation offering sections. There you describe the different data sets offered by the SOS with their spatial extent. You can add a short abstract. So this describe spatial data set operation can also be covered by the SOS get capabilities operation. So that's more for the downloading of whole data sets. For getting individual spatial objects, so individual observations or subsets of observations, the SOS immediately offers also the get observation operation, which has all these functionalities and filters you need for subsetting the data which is available in your database. Describe spatial object, it's also included immediately in the get capabilities because you have the information about the observation type, for example. And then the last aspect is the search criteria for this get spatial object operation. So these filter criteria you have to provide for defining which spatial objects, so which observations you would like to have. That's again included in get observation. So it's basically you can map this to basically two operations of the SOS interface. I also mentioned describe sensor as an additional operation. That's mainly in there because we want to stay SOS compliant, and SOS standard requires to have describe sensor in place as well. But the core Inspire functionality can be covered by two of these SOS operations. So now let's go a bit more through the different parts of the technical guidance. So the first requirement that we have is if you want to implement a predefined download service, dataset download service, we just require that that should be conformant to the SOS core, so the minimum of the SOS standard as defined in the SOS 2.0 standards document. So just saying, if you want to implement a direct download service, predefined dataset download service, you have to set up an SOS 2.0 compliant service. Next requirement is about the spatial filtering profile, because we have to make sure that the references to spatial locations are included in the observations, that we can filter based on these spatial properties of an observation. The next requirement is you have to have an SOS with the spatial filtering profile supported. That's one addition, but that's included in the SOS standard, and you just have to implement that. Then the next requirement is that you have to support both the key value pair binding core, so that you can send GET requests to your SOS servers, and the XML encoding for POST requests. So these are pretty much things which are covered by nearly every source. Spatial filtering profile may not be in everyone, but it's something which can be expected from up-to-date SOS servers now. So then the next requirement is how to organize the data in your SOS. So the big question always is, if you are dealing with observation data, what is your data set? If you have predefined data set download, you need to make some kind of convention what to use as a data set. And in SOS, we have a nice thing which is called observation offering. Observation offering is a mechanism in SOS service how to structure your data. So you can structure your data based on their geography. So you can summarize data for a certain area in your offerings. You can organize data for a specific thematic field. So for example, ozone measurements in one offering. Or you can organize it also by temporal characteristics. So data for 2013 can be put in one offering, or you could even combine that ozone data for 2013 in one offering. So you are quite free how to organize your data. That's also important because different domains have different ways how to structure their data. And so there's just a requirement. If you are providing the direct download, predefined data access download service functionality, you have to define offerings which are then considered as spatial data sets. So the next thing is you need to provide some additional Inspire metadata. For example, some extended capabilities that's defined in the technical guidance already. And you have two options to do that. So you can do that by referencing in your capabilities document to another place where this Inspire metadata is there, or you can put that directly into your capabilities document. So the next requirement is if you have an SOS used as download service, you also need to provide the Inspire metadata either as a link in your capabilities document or directly included in there. So this is a bit more complex, but it's just about one big topic. It's about that you have to support different languages, or that you at least have to define which languages your service is supporting. So multilinguality, that you have if you are offering multiple languages, that you have a query parameter that you can use for describing in which language the response should be returned. You can request for a specific coordinate reference systems. You have to consider Inspire namespaces. So these are three additional factors you have to add because they go beyond the basic SOS interface. So you need to add to the SOS parameters for language and CRS in which the responses should be returned. And yeah, for that purpose, there's a set of requirements in the technical guidance, in the proposed technical guidance update, which basically deal with this, how to handle the CRS, how to handle the language parameter, and yeah, how that should be defined. For the capabilities, here's one example. The parameter for this language request should be language, as it is also done in other download services like the WFS. We are doing nothing new here, just taking what is there, apply that to the SOS. And here you have one example. You have such a URL, and that's a get capabilities request. In the end, you just put there an additional language parameter, and then the metadata will be returned in the way you would like to have it. Then we have several recommendations, although that's not required by the network services specification. There should be some enhancements like, or we recommend that there should be multilingual error messages, multilingual support for other operations like describe sensor, get observation by ID, or get feature of interest. Then, like for the language, we have also made statements about the coordinate reference system, the CRS. Basically, we say if there's no CRS provided, we have a default coordinate reference system that should be used, ETRS 89. Also, if we have additional operations like get feature of interest, where you can get the geometries associated to an observation, then this should also be implemented. So that was pretty much about the predefined dataset download, how that can be realized through the SOS. Basically, our message is you can take a regular SOS, make sure that the spatial filtering profile is enabled to handle the observation geometries. You have to include a language parameter, a CRS parameter, and then you basically already have such a download service in place. And the next step is to look at the direct download, direct access download. And yeah, pretty much you have to follow all the requirements of the predefined data set. And in addition, you allow the subsetting of your data. And for this, you get some additional query parameters. The minimum spatial profile is already there. You have to filter, be able to filter your data based on your on the geometry. Bounding boxes have to be supported at least. You have additional attributes that you need to support for filtering. Observed property. So what is the parameter observed by the sensor? The feature of interest. That could be the identifier. Which station are you interested in? The procedure basically in terms of sensor web, that means the sensor that has gathered the data or sensor type. And you have to include the temporal filters that you can ask for data during a time period or at a specific time instant. And potentially also having the requesting for specific observations by their ID. But that's all functionality which is already included in SOS, so you get that basically out of the box. One thing that is not so straightforward here is a spatial data theme as an additional spatial query parameter. However, if a user connects to a specific SOS, he already knows about the spatial object he will expect. So yeah, for SOS, it's already clear if you connect to a server with spatial data theme you are requesting. So that's more or less about the functionality. So you can realize both the predefined data set and the direct access through the SOS. And now the next thing is how does SOS relate to the other types of download service? And there we also have defined different hybrid approaches. That means that you can access the SOS or combine the SOS with other types of services like the web feature service. The web feature service is the service for serving geometries. If you have an SOS, have your station network creating these measurements, you could also refer to a WFS for providing the geometries of your stations, or perhaps even more complex relationships between these stations. You can also link to Atom for that, so that's described. You have so different ways how you can share the functionality and put certain parts of the functionality to those services which are best suited for the different type of data. So that's the quick overview of the technical guidance updates. I didn't dive too much into the specifics, but because I think that's too much for today. I think the documentation will also be soon available somewhere for download, the proposal update. And then we can also discuss that more detailed. Do you have, at the moment, any further questions about this technical guidance updates? I think that's more technical on this part.
Well, it's a general one. Are those technical requirements, are they tested in reality? Or?
Yes. You will see at the end of this session or beginning of next session, we have a service running where you can see how that works and how the data can be requested. So we have connected that also to clients, implemented all these enhancements to really see that that works.
We just wanted from the very beginning to have the document together with the solution. It makes sense really people to interact and then to see what's written or vice versa.
Maybe also to add that there are two kinds of requirements and recommendations in the document. Some of them are related to the software, basically for the development of an SOS solution that needs to be enhanced, for example, additional language parameters and so on. But most of them are basically for the data provider, how they have to basically set up their data set in SOS.
Yeah. But they are also
that basically has been tested as well. But one of the things that we would like to do now is also ideally using other software as well. So basically just to see whether the guidelines are clear enough for data providers to know what they need to do in order to put their data into an inspired SOS software. And that's, I was quite happy to hear there's a lot of data providers in the room, so hopefully we can find one or two more from the audience here that can help us with testing this in a broader sense.
Okay. Any further questions? Oh, okay. So the next presentation that I'm going to show you goes directly into the direction Michael has mentioned, because so you have now seen this technical guidance updates that may be quite abstract, but if you are a data provider, your big question may be, how can I implement this in my system? How can I provide my data in the SOS compliant way? And there I will show you some approaches that have been also tested in practice, and there you can see what could be a way that fits your needs, your existing infrastructure, and how could SOS be coupled to your existing systems. So the software, the prototype developed in this project will be available as open source software. So there's no cost for you to get that software in place. It will be included in the 4.x development line of the 52 North open source SOS implementation. So it will be really available in regular software that will be available under a GPL version 2 license. And now what I'm going to present is different options how this specific piece of software can be integrated in your existing IT infrastructures. So this is perhaps one of the most typical scenarios. Many data providers we have been working with have their data in some kind of big observation database. So that could be a MySQL database, Oracle, PostgreSQL database. Recently we added also support for Microsoft SQL Server, and many organizations already have their data in place. And what you can do, or what you could investigate is a very fast way to integrate that without doing any programming work on your software. So you have your database in place, and you do leave that database untouched. So you do not have to change anything in your existing database. That is something we wanted to avoid. Then you have this SOS server implementation, like the 52 North SOS 4.x development line. And this server features a so-called abstraction layer, the Hibernate framework. And that framework allows to abstract on the one hand from different database management systems. So it doesn't matter if you are using Microsoft SQL, Postgres, Oracle, whatever. As soon as it is supported by this Hibernate layer, which is a very established open source project, you can connect to this database management system. So that's the one aspect. And the other aspect is about your database model. So the SOS needs to know in which table of your database, in which column are the timestamps for the observations, where are the measured values, where are the station IDs. So all these different types of information you need to fill in such an XML document is usually available in most databases we have seen in practice. And what you can do with Hibernate is to create some kind of mapping, some configuration files. It's not so easy that you can just type it in there. You have to do some thinking, but in general, you can use these text files, these text-based configuration files, to describe in which table is which information located that is needed by the SOS. As soon as you have created these mappings showing the mapping between the SOS data model and your database model, you can run the service and the data gets available. So that's an exercise, for example, we did 2 weeks ago for the Swedish air quality data, and that data you have already seen that in the client is now available through such a SOS server. Another typical scenario is if you do not even want to touch these Hibernate configuration files, you can use database views. So many people are quite familiar with their databases. They are able to create views, and the SOS comes with a default data model or default database model. And as long as you create views that correspond to this database default model, the SOS can immediately connect to your database. So that's an approach that was followed, for example, by the guys from Belgium. They have set up, they have a running Postgres database. They created views which correspond to the database model the SOS is expecting, and then they were able to set the SOS also in a very fast manner without doing any programming work. Then we have some specific cases where countries have some additional requirements, where some information is missing in the database, where the information has to be merged in through other sources. In these cases, it's also possible to customize the SOS. However, in that case, you would have to do some programming work where you customize a specific layer in the SOS. So the SOS is built up in a way that you have different layers, and one layer is the data access layer. This data access layer basically is a set of program code written in Java, which describes how to request the data from the database. So in that case, in some cases, we need to adjust the SOS to specific setups by doing some programming work. That was, for example, done for some environmental data from Germany, from the Umweltforschungszentrum in a national research project. So that's a potential way, involves a bit more of work, but could also be feasible for some of you. So then we have another typical setup. If you do not have a database in place, or you do not want to couple the SOS to your production database, you could also use the default database model. So the default way to install the 52 North SOS is take a Postgres database, install our default database model in that database, and then put the data in there. And the SOS has some additional operations, the so-called transactional operations. They are not required by Inspire, but you could use some standardized operations. They are called insert sensor and insert observation. And then you just send XML requests to the SOS containing your data, and then the SOS takes care of putting the data into its database. That's, for example, an approach we have followed at the JRC for their setup. They have installed the default Postgres database using a tool for importing the data, installing or loading that into the database, and, for example, taking that from CSV files. There's a tool for converting that to SOS requests, putting that into the database, and then the data gets available. Another typical setup is if you want to use, or if you have your database in place or some other part, and if you also in this case do not want to use your existing database, but you want to set up a dedicated database for serving the data through the SOS. In that case, you can also install a Postgres database with the default database model and put in some kind of SQL script, some SQL feeding mechanism to push the data into the database. That's, for example, followed by the team of GeoNovum in the Netherlands. They are regularly harvesting the data from another database available at REVM. Then they are creating some kind of SQL statements. In this case, I think it's packaged into some kind of JSON request that's sent to the SOS and pushed in the data. This approach is also, for example, followed by the Wupperverband, a regional hydrological authority in Germany. They are also having some additional quality checks on their data, some additional tools, and then they have a database script taking care of pushing the data as soon as it is quality controlled in this database, which is suited then for publication. And then one final approach I would like to show you is about the setup that you can also encapsulate proprietary services. That is an exercise we did, example, for the German Federal Waterways Administration. They have a set of web services available delivering their data. These were SOAP services with an open interface, but nothing like any OGC standard or something like that. And what we basically did is to develop some kind of proxy. In that case, you can also exchange the data access layer of the SOS, connect this SOS then to this proprietary SOAP service. And if you get in such a GET observation request in the SOS standard format, then this proxy translates this to the format of the proprietary service, sends the request there, gets the data back, and then converts it again into observations and measurements to become, for example, Inspire compliant, and returning the data. That's for those scenarios where you have, for example, well-defined access points to your observation data, which are through, for example, web services. For example, because you do not want to have any further software accessing your database, then you could encapsulate this proprietary service with an interoperability proxy SOS, which then takes care of making your existing service standard compliant. So that was one overview how the SOS can be set up. And the idea is really to show you that there are different ways how to make your own observation data available through an SOS without changing your existing infrastructure, because that's something we got the experience is very important. If you want to provide the data, you need a tool which allows you to do this with very low effort on your own development resources, and that can be achieved through this open source implementation we have been developing also in this project. So thank you for your attention, and that's it for this presentation. Do you have any questions?
Are you going to be documenting what you've just presented together with the software?
Yes. So
kind of step-by-step,
our idea is that we want to have some kind of guidance document in our community also, giving people some more detailed advice how SOS can be applied in their infrastructure and under which conditions which solution could be the best one.
Yeah, because that is, I think, something that we're in general missing in the Inspire guidelines, the step-by-step guidelines on how to get from where you are to this situation described in the technical guidelines.
Exactly.
I think that's very useful.
Yes?
Those setups, they assume that the sensor itself is already
Yes, so I think at least for many environmental agencies we have been working with, that was the case. They have their very sophisticated measurement networks in place with very complex, sometimes wireless communication strategies, very energy efficient, and that's something they have been working on for years, and which they do not want to touch because it's working well and would mean a high investment to change that. So the ideal point is to set up this infrastructure on top of the database. However, looking at the transactional operations or lightweight implementations of these, you could even consider using the sensor link for loading the data through that into the SOS. But in practice, I think at the moment, mostly it will be set up on top of existing databases. Exactly. That's also because many agencies have to do quality control before they can publish the data. So that's often a limiting factor before it can be provided to the public.
And if you get to that Raspberry Pi situation,
Mm-hmm.
the data is already processed on the sensor itself. Is that the same situation?
Perhaps, Alex, you did some experience with that, Raspberry Pi and SOS.
Yes, we actually managed to. Raspberry Pi, just for those of you who haven't encountered, it's a credit card-sized computer which has low consumption and costs 25 euros. So quite impressive. Just out of the box, you will plug it in and there's a Linux installed on it, so it's really generic. We managed to deploy 52-degree SOS on top without even trying to do an optimization, without removing the graphical user interface and so on. So we've experimented, it delivers, and it also runs the database. So this is potentially, in the long term, a very interesting solution, also answering the question of sensor node, which is service enabled, which might be interesting because this is within the network itself and not really having necessarily to have a database and then go to the infrastructure and stuff. So different approaches, but this is just still on the in the research area. It's not really mature to deliver.
So also linked maybe to the energy sector or domain that is dealing with smart metering and smart meters. Is there any?
Not yet. Not yet. I think the driving factors were in the moment more in the environmental research area, because there were also some needs to get the data public and make that exchangeable. In the smart metering, it's sometimes a bit more closed, and so they want to share the data in a very limited scope. And but yeah. Yeah, but it could be applied there. We have already had some first talks with some colleagues in some European projects who are thinking about that concept, but there it's still developing. So the main activities are moment, environment, hydrology. These are the big domains.
Smart grid and smart city.
Yeah, exactly. As you are mentioned, these Internet of Things activities in the Netherlands. We are also trying to participate to this pilot by providing this open source software to certain scenarios where that could be helpful. Okay, any further questions? Okay, then I think we can start with some demonstration. Let me check how to make that a bit more visible. So we didn't expect that many participants, so no, that's great, that's great. But I have to make sure that now also the people in the last rows are able to see something. So first, what I would like to show is some request. Oh, that's too much. So we'll do it that way. So if you start interacting with an Inspire compliant SOS server or with any SOS server, the first thing you usually do is to send a get capabilities request. And this get capability request is basically structured like it is structured in every OGC service. So you have the parameter SOS that says, okay, I'm talking to the SOS using the SOS interface. My request is get capabilities. And then to be Inspire compliant or to make use of the Inspire capabilities, you can add the language. That's done this way. So you add the language parameter and language, in this case GER for German. So let's take this request and we put that into our browser. Okay, so it's not so nice formatted, but what we have done now is we have started an SOS server on this machine here. We have connected to that. We have sent the get capabilities request to that server, and we want to get some information what is available in the SOS. So we get some information first about the we get the title, then we get the abstract, and what you can see here is now we have Inspire Downloaddienst basierend auf dem OGC SOS. That's German. We have sent the request in German to the SOS and get the according abstract in the right language. We can change this now, for example, to ITA for Italian. And then, where are we? Now we have an Italian abstract. So that's the first part where you get then this language customization into the SOS, get the extended requests. And then we can also scroll a bit through this document. Profile, this is the specific parts of the SOS standards which are implemented by this instance. So it's quite long. Then service provider, so that's typical information you have in all OGC services basically. Then operations metadata. There's a lot. I have installed the full version here. Get capabilities here, then you get the get URL, for example, to execute the request. So here you get then allowed values for the parameters, the observed properties, for example, which are supported by the SOS. So that's all the operations of the SOS with their valid parameters that you can apply. And what's getting interesting again is we have to go further down. Version cap. Here. Oh, where does it start? Okay, exactly here. Then we get to the observation offering sections of this capabilities document, and there we describe which data is available through the SOS. And we start here with a short description of this offering. It's air quality data for the station. We have an identifier for this data set. Then the supported CRS as EPSG codes. So you see there are some EPSGs supported. We have the languages. Default language is English. If we do not provide the language parameter, we get the data in English. Otherwise, we can select English, German, or Italian in this demonstration instance. We get the procedure, the sensor. That's a JSC weather station. The procedure description format, in which format can we get the metadata, it's SensOnL. And then we get a list of observable properties. Observable property is the parameter the station is observing. So we get the information. We have carbon monoxide, nitric oxide, nitrogen dioxide, ozone, sulfur dioxide. So several parameters which are measured at that station. We get an observed area. That's the bounding box which is covered by that station. That's an in situ sensor, one station. So in this case, the area covered is 1 point. Phenomenon time, that's the time period for which data is available for the station. So that's for 6 months in 2012. Response formats, so what's important is you see O&M 2.0, which is the response format. However, in addition, you could also get a JSON encoding, and WaterML could also be applied to encode this data. The observation type, O&M measurements, so that means it's a scalar value which is returned in the measurement information, and the feature of interest type, saying the geometry to which the data is associated, that's a sampling point, also, so one station where it is located. And basically with that, we provide such a section for every data set available in the SOS. You get a very clear view which data is available, which data can be requested, and yeah, how it can be downloaded. Looking at the time, we are now at the time for the coffee break, or should we continue? I'm not sure. I think let's go for the coffee break, and then we will show the get observation operation where you can download the data after the break.